Okay, so before we look at section 8.2, let's review 8.1. In 8.1, we were estimating mu, the population mean, when we did know sigma, the population standard deviation. So what did we need? We needed that x bar was normal, it was normally distributed, and we knew that by the central limit theorem in one of two cases. Either x was normally distributed, or our sample size was large enough, it was at least 30. Then, given the confidence interval level we were interested in, we found our z sub c. We used our z sub c to find the error, along with the standard deviation sigma and the sample size n. Then once we knew our error, we found our interval, which was our estimate for mu, and our interval was x bar minus the error to x bar plus the error. So the first point here was crucial, that we needed that x bar was normally distributed because we're using z sub c. That is our variable for our standard normal distribution. So we needed that x bar was normal. So in section 8.2, we don't have quite the same situation. In 8.2, x bar may not be normal. And we certainly don't know sigma. We only know S. So we don't know sigma, our population standard deviation, but we do have the standard deviation of our sample. So instead of a normal distribution, we're going to be using a T's standard distribution. So our normal distribution is symmetrical, mound-shaped, and it tapers off. It's centered at the mean. Our T's distribution, students, so our students T distribution is also mound-shaped, but it doesn't fall quite as quickly. So it has higher tails, oof, that's not so great looking. I'll show you another picture. So it's still symmetrical, still mound-shaped, still centered at the mean, but doesn't taper off quite so quickly. So let's look at another picture where we see these two graphs, where we see the normal curve and this other distribution side by side. So this is from the online statsbook.org that we saw something else from in section 7.5. So it's a little hard to see, but it's also, there's a link in Blackboard as well, so you can look at it on your own. So there are two curves here. There's a red curve and there's a blue curve. So down here it says the normal distribution, so this is the standard normal distribution, is the red curve. The blue curve is the T distribution. So you can see they're similarly shaped. So let's look at the difference here. The blue one is the student's T distribution. It doesn't fall quite so quickly. Its tail is a little bit bigger, whereas the red line falls much, much more quickly. So let's look at the whole image again. This DF over here stands for degrees of freedom. That's basically the sample size. So let's see what happens as I change the sample size. Right now, if you look at the tail, you can see the distinction quite clearly between these two graphs. As I make the sample size larger and larger, I'm moving the slider. You can see down here, it says that the DF is 15. As I change the slider, it's growing, growing, growing. These two curves look essentially the same. So as the sample size gets larger, the student's T distribution looks more and more like a normal distribution. So here, now that I'm at DF is 48, you cannot tell them apart, or hardly at all. Let's see what happens as I make them smaller. You start to see them come apart. You can see this distinction there. Okay, so what we're going to be looking at in this section is doing a similar process under slightly different conditions. So instead of using a normal curve, we're going to be using this student's t distribution instead. So we're going to have a different table to look at, but overall it's the same process. Instead of z sub c, we'll be using t sub c. So now you can take a look at the slides and the video that goes with the 8.2 slides.